Regarding the nearest neighbor relationship, let us first observe that, at least in general, the nearest neighbor relationship is asymmetric. Let me explain what I mean by this. Let us consider the example shown in this slide. Of course, it may happen that the nearest neighbor relationship is symmetric. For example, the nearest neighbor of instance number 1 is instance 2, and as shown in this example, the nearest neighbor of instance number 2 is instance number 1. Here, in this graph, the directed edges point from each instance to its first nearest neighbor. However, in general, the nearest neighbor relationship is asymmetric. For example, the nearest neighbor of instance number 4 is instance number 3, whereas the nearest neighbor of instance number 3 is not instance number 4, but somehow instance number 2 is closer to instance number 3 than instance number 4, so the nearest neighbor of instance number 3 is instance 2. As the nearest neighbor relationship is asymmetric, we may count how many times each instance appears as one of the k nearest neighbors of other instances. In this example, instance number 6 appears as the first nearest neighbor of two other instances, whereas instance number 4 never appears as nearest neighbor of any other instances. Generally, we use nkx to denote how many times an instance appears as one of the k nearest neighbors of other instances. In order to keep this example simple, we use k equals 1 throughout this example. So, in this example, we count how many times an instance appears as the first nearest neighbor of other instances. Once we calculated n1x for each instance, we can plot its distribution. This is shown in the upper right of this slide. As you can see, there are 4 instances in this example which appear as the nearest neighbor of two other instances, whereas there are only 2 instances which appear only once as nearest neighbor. Additionally, there are 4 instances which never appear as nearest neighbors. The question is, how does this distribution look like in case of real data? And this is what is shown in the bottom of this slide. As you can see, these distributions have a long tail on the right, which indicates that there are a few instances which appear surprisingly frequently as nearest neighbors of other instances. Such instances are called hubs. And the phenomenon that the distribution of nkx is substantially skewed is called Hubness. Usually, Hubness is quantitatively measured by the third standardized moment of the distribution of nkx. This third standardized moment is also called skewness.